Next, let's look at how to solve absolute value equations graphically using Desmos. If we look at this problem, here we've got an m inside the absolute value, an m on the right that's not in an absolute value. It does look a little more complicated, so let's use Desmos for this one. So I'm going to bring up Desmos on my web browser. At this point, we should have our Desmos settings already done. We do have a tutorial in the top module on our Canvas page. If you have forgotten how to do the settings, you can go back and look at that. Now, to solve the equation, I'm going to have to put our equation in the very first line. First, let's look at it the way we did when we were solving equations for our Algebra 1 review. I have the absolute value, and I need to find that, so I'm going to hit this keyboard down here, and I see this absolute value right there. And that absolute value of 2, and I can't use m, I have to use x. So I'm going to do 2x minus 3. Oh, that has to be inside my absolute value bars. Minus 3. And then if I right arrow out, that takes me outside. So then I'm going to go put in my equal sign, and I have x plus 4. Now, if I look at this, and I try to click on my x-intercepts, that doesn't work. So what I'm going to have to do here is I'm going to have to split it up. So I'm going to take the second part, and I'm going to put that down into the second line here, x plus 4. So what I'm doing is looking for the intersections, kind of like how we used our TI-84 calculators in school for geometry when we did y1, y2, and looked for the intersections. That's really what we're doing here. Now, I can drag my graph or I can zoom out, but what I want to see is any intersection between these two lines. So if I click right here for the intersection between those two, I see negative 0.333 for the x value. If I look at the intersection over here on the right and click on that, I see an x value of 7. So let's take a look at this with our problem. Our graph looks something like this. So we had the absolute value of 2x minus 3 in the first line, x plus 4 in the second, and we found our two intersections. Our possible answer choices are the x values at those intersections, negative 0.333 and 7. So that's my possible answers. Let's try another one. Here, we've got the absolute value of 2x minus 7. And then outside my absolute value sign, I have plus 1 equals 9. So let's try this in Desmos as well. We're going to bring up our web browser again. And I'm going to put the left side of the equation in the first line. So just like we had to do on our last problem, if for absolute value, because there could be two possible solutions, Desmos does not like to give us the x-intercepts. So we do have to split this one up. I can hit my keyboard button for my absolute value. And inside we had 2x minus 7. I could right arrow out of that absolute value, put in my plus 1. I don't really need that keyboard anymore, so I'm going to drop that back down. Now, if I put 9, that right side, here by itself in the second line, it doesn't do anything. Desmos doesn't know what to do with a number by itself. So remember our y1, y2. So y1, they're really treating it like y equals the absolute value of 2x minus 7 plus 1. So for the second line, I'm going to put y equals 9. And that's going to give me the line that I need. Now, I see both intersections, and I'm going to click on them. On the far right, I've got 7.5. On the left, I've got negative 0.5. So let's go back to our problem and take a look. So when we graphed it, we got two possible answers, negative 0.5 and 7.5. Now, those don't quite match up. We have fractions here. What we can do is go to that third line in Desmos and type in those fractions. So if I type in 17 divided by 2, or 17 over 2, in that third line, it gives me an equals at the bottom, and I see 8.5. So I know that 8.5 doesn't match either of my answer choices. So I'm going to mark out A. Let's look at the next one. I'm going to look at C next. So I have negative 0.5. So in Desmos, in that third line, if I just type in negative 1 over 2, I get negative 0.5. So we know that that's equal to one of those answer choices. So that's the one I pick. Now, once in a while, you'll come across a question that asks how many values of x will satisfy each of the following absolute value equations. How many values? It's not asking what x is. It's asking how many answers we have. So when we go to Desmos, we want to know how many intersections we see. So for this one, let's bring up our web browser again. And in the first bar, I'm going to bring up my keyboard. First, I need negative 7. Then I want my absolute value. 2x minus 1. And remember, we can't do the equal to 0 here because that won't give us our answer. On the second line, and then remember, if we have just a number, we need y equals that number. So if I look at this one, I can zoom in a little bit to see. And I can see we have one intersection right there. So let's look at our problem again. Now here, I don't need to find x. I don't need that number. So when we look at our graph, we had one intersection. So 1 is our answer. Okay, so last part, we need to be able to graph the solutions. Once in a while, we'll either be asked to find the graph with the solutions, select the numbers on the graph, or actually graph it. So we do need to know how to do that. For this one, when I put it into Desmos, we get our intersections at negative 14 and 2. So our solution is negative 14 and 2. And you notice for this one, I had y equals for both. When you have x in the term, you don't have to have a y equals at the beginning, but you can if you want to get in the habit of it. On the right side, we had 4, so I did put y equals 4, and we got these two answers. So when we have negative 14 and 2 as our answer choices, I'm going to put a single dot at 14, and then a single dot at 2. All right, so that is it for solving absolute value equations. Let's take a little bit and practice before we do our classwork for today.